I'll explain the meaning of my talk title afterwards, but you can probably have a few guesses on what it means. Simona told you who I am. I do lots of things. I don't sleep much. Sleep's overrated. And seems like there's been a lot of history today, so I won't spend too much time on it, but I want to take a quick trip back to 2004. So 2004 was kind of when JavaScript was first thought of as a real programming language. Before that, I would say, I'm a JavaScript engineer, and someone would say, you mean like Java? And I would be like, no, not like ham is to hamburger. And so that was always good and fun. And last year I was at a conference, I don't remember which one, but I heard someone explain they were a Java engineer. And someone said, you mean like JavaScript? So the point of that year is Flickr was out, and it was the sort of birth of Web 2.0 and a lot of interesting things. It was also the year that Gmail was released on April 1st. It was not a joke, but it was the first time when mainstream people thought, hey, this JavaScript thing, this could actually be big. I had been foolishly experimenting with it for about 8 or 9 years already at that point, and having a lot of fun, but not getting taken very seriously. Started working on a JavaScript framework called DOJO, which some of you have heard. It's also the year that Google acquired a couple of companies to make Google Maps and Google Earth, which were released later the next year. And it was roughly the time that the lovely, now retronym Ajax was coined. Ajax was cool. At one point, it meant everything you could possibly do that was cool in a browser was Ajax. I don't know why I'm talking so funny. It's kind of fun. Anyway. I guess I'm just trying to get you warmed up for the after party and the smoosh stuff. So it's a really great time, a really big transition when JavaScript went from something you would use to sort of modify forms and images to something you would use to create entire applications. But it also introduced the architecture of a single-page application, which is really great in that, hey, I can do everything I could possibly want to do in an application, but it introduced a series of problems. The most commonly noted ones, or besides the ones we've ignored, are search engine indexing, navigation, bookmarking, and performance. And by performance, I mean relative to plain content and relative to native applications, and today relative to mobile applications, right? And so these were all things that, like, great, we've fixed these problems, but we've introduced a whole new set of problems that the web used to fix. And over the past many years, we've come up with many solutions for some of these problems. For example, search engines have gotten better. Well, at least Google's gotten better at indexing JavaScript applications. Routing or routing solve most of our navigation and bookmarkability problems, as well as the history APIs that we access. And we have various optimization tools to make our applications faster. We've had build tools. We now pretty much rely on Webpack or Parcel or something else. And HTTP 2.0 can potentially reduce the number of requests. But we still have everyone's favorite application experience, the spinner. This will not let you think your application's slow. It's responsive. It may sit this way. Spoiler, I don't have anything after this. So if any of you have heard my co-founder of Dojo, Alex Russell, talk, he's very vocal on Twitter. He might even be the butt of some of the smush jokes tonight. I don't know if they have new humor or not, but basically he's always talking about those poor people in the middle parts of the world who are on like 2.5G connections with feature phones. And I'm like, Alex, can't Google just buy you a new phone and get you good service? But anyway, it's pretty funny. So obviously, slow connections are a problem, but for the most part, we've really been focused on the render function. And whether we're talking about the render function of like React or Vue or Dojo or a framework, or how we render applications maybe on the server, maybe we create static versions of our sites, and that's kind of what this talk is about. And it's a pretty simple talk because I sort of thought this was like the end of the day and I wasn't going to overload you with code. So some of the goals of a solution to make the single-page application architecture have better performance would be to improve our initial page render time, right? We want the application to actually load faster and be viewable faster. We want it to be populated with relevant content initially, but we don't want to lie to our users. We don't want to show them a news site with content that was the last time we optimized the site 6 months ago. We want to show them stuff that's real and relevant to what they're viewing today. We don't want to have to change the way we write software. It really sucks, and it's really brittle when we have 3 or 4 different code paths or different mechanisms to release software under different conditions. We want to still be able to get all the benefits of building software on the web, right? We don't want to say, well, okay, I've done all of this great JavaScript work to now deliver static websites with no upside. So there's a case study done by AWSMR about Netflix last year, I think. And essentially, they took out, for the pre-login version of Netflix, React from the front end, and they streamlined it down, removed the JavaScript. And the results were pretty substantial. As you can see, they had nearly 600 kilobytes of JavaScript, and they reduced it down to somewhere around 130, let's see. Yeah, like 112, right? And so, of course, their page load times were greater, and everyone was like, oh, that's so amazing. How do I do that? And, of course, the answer is like a lot of work and a lot of custom effort and so on. So I'll look at some solutions. But first, I think it helps to think about what performance really means. And if you've read about a lot of the common new performance metrics, this is nothing new. There's the time to the first byte. And that's basically, you click on a link and you see the first bit of content. And that's sort of a measure of how slow your network is or how slow your application is to get to something useful. There's the first byte, which is the first visible pixel. But I think the more interesting ones are the next two, which is the first contentful paint. That's such a terrible name, but which is you can actually see the content that you've requested visible in your application. And then the most important one, which is the time to interactive. So the time when the application that you've created is something you can fully engage with and start to use. So these metrics matter because a lot of performance, you can't just make everything infinitely fast, right? Some things take time. But the more you can do to deceive and lie to your users in a way that's respectful, the better off they're going to be, right? So if they feel like, yeah, it's going to take 5 seconds, but all along the way, I'm making it feel like I'm getting there faster and faster, that's great, rather than just that single spinner blocking your whole application for 5 seconds. So there are a number of different types of approaches we can take to render our application. The most common one JavaScript applications use today is client-side rendering, or a single-page application where we send a bunch of JavaScript down the wire, our HTML page is pretty much blank, and then we get some content, get some bundled JavaScript, and then we render client-side. And you'll see at the bottom there's this red squiggly, and that red squiggly is when we're blocking our flow. And so this is great, except when that JavaScript bundle is really large and that render takes a long time, the user's waiting quite a bit of time for something to be useful and something to happen. So then people have been talking about server-side rendering. And server-side rendering is kind of a step back in time where we go back and we render all of our stuff on the server and deliver some static websites, and that's great. Except that it's not ideal because we still have to render a lot of the HTML on the client side, and then it's not necessarily in a state that we can do anything interesting with it. So there's this concept of rehydration, where you take your server-side content in an initial state, and then you add your JavaScript, and then you upgrade it to what you would have done if you had done pre or client-side rendering. And that sounds great, but in practice, the result is first the user sees some stale content, and then you have to take all the time to render it on the client side. So it's actually slower overall by quite a bit than just pure client-side rendering. And that's, again, because we're blocked on quite a few things. So the technique that our team and other teams have been working on recently is, we call it build time rendering, but some people call it pre-rendering. And the idea behind this is you could use this for a static site render, or you could use it for a static site rendering plus rehydration. And the beauty of it is you're just pre-rendering and optimizing the bundle for the stuff that's sort of infrastructural but not content, and then you're loading the content into your page as it's needed. And you'll see it sort of like allows streaming, allows other things. It's just a lot of optimizations that are supported that you might not expect otherwise. So unlike a few years ago when people were like, yeah, let's just server-side render things, and be like, well, that's kind of going back in time. Now, one of the benefits of a heavy JavaScript application was we don't have to put all of these servers up in place and manage the resources and the cost to do that. We can instead put that computation power down to our users. But also, we can think of the network as something that's sending data rather than the server just delivering data and APIs, rather than the server being responsible for constructing the state of our application and doing all of the work. But a traditional SSR approach actually is going back in time, so we're trying to avoid that. So, like I said, SSR plus rehydration is okay. It was a nice step, but it's not sort of the final step. And the reason is that, it's probably the easiest approach to work with. And one of the common libraries to get that working is Next.js, not Nest.js. There are versions of things like this for Angular and other frameworks as well. This one is for React primarily. And it basically works. It solves some of the problems that we have. But where it sort of lacks the ability is that, in my experience, it gives us inaccurate information up front. The stale news article, the static content that's sort of optimized in advance. And we sort of lie to our users. The app looks like it's fully loaded. The user goes to click on a link, but the link's not really in a state they can interact with it. So that's where we came up, and others came up with the idea of build time rendering, which is it's sort of twofold. You could create a static site with it if that's what you wanted, maybe for a documentation site for your open source project. And I say that because that's what we're doing exactly right now. Or then you could recreate the site with that initial render and rehydrate it. And you get this kind of classic UI experience where we're not lying to the user. They know the page is loading, but then we're basically quickly replacing it with real content once it's ready. So I'm going to go through a couple of quick code examples because code talks aren't real if you don't show any code, and that would be a fraud if I didn't do that. But basically, imagine the use case where we just want to read a markdown file and parse it into HTML. And I'll look at two things. I'll look at GATSBY and I'll look at DOJO. So GATSBY is primarily used with React, and DOJO is, of course, DOJO. So GATSBY basically takes some data, puts it into equivalent of a GraphQL style resource, with the assumption being that if you're writing a React application, you're probably using GraphQL. It's not part of sort of an integrated React framework, but it kind of builds on top of it. So what that means is that you kind of work with this on an application level rather than a component level. And then essentially you deploy it to various sites, and they can be static or dynamic. And it looks like I cut off my text, so that's awesome, but no worries. So the GATSBY approach is sort of 5 steps. It uses GraphQL to provide your content and query against it at build time. So if you know and love GraphQL, that's pretty simple. But that does take some time to take that static markdown content and parse it into GraphQL to then query against it to then render it into markup. I think I just skipped all 5 of my steps, so that's cool. Yeah, I'll just move on then. Well, I probably have a bunch of transitions because I like animations, so yeah. And one more. Woo, swoosh. All right. So, sort of showing that in action, you have a typical GATSBY configuration file, and it looks a lot like any other configuration file you define, and you define some options and some paths and what you're going to do. So that's pretty straightforward. Just copy and paste that from the GATSBY documentation. And then you essentially set up a template. You import React, you import GraphQL, you define your template, you export it, you pull it in a markdown parser, you define your JSX for your thing, and then you put some inner HTML in there. And then you essentially query against GraphQL, format that into HTML, make that available for your application. So pretty straightforward. Like GATSBY's great, right? It's not doing anything wrong here. DOJO is taking a fairly similar approach with what we call BTR, or build time rendering. That's like the first clue that the talk was not called better, but build time rendering. And probably the main distinction is DOJO provides this as part of its entire framework. And so we're able to sort of seamlessly switch between using build time rendering and not using build time rendering. And we're able to provide this on a component level. So it's fairly easy to say, here's like a data grid that's backed by some markdown service without having to sort of recreate this entire top-level GraphQL infrastructure. And it's typed like a normal widget. And so the idea is we've got basically component level reusability and awareness of things that would happen on the server side. And then we've got this feature called a block. And what a DOJO block is it's a set of code that can be run at the time we're building our code, so build time rendering. And you can do anything you can do in Node at that time. So you could read a markdown file, you could parse images, you could do anything you could do in Node and use that as part of your build time rendering step. So Dojo sets a flag, basically a feature detection flag, to determine if you're in build time render mode. So within your component or widget, you can sort of do conditional logic based on that. And that's kind of the only change you would make in your application in terms of your rendering, in terms of what gets displayed. So then you might define a block that looks like this. And in this case, you're like, this is client-side code, but it's all sort of server-side code, right? And then we're basically importing from the file system. We're, in this case, importing the showdown markdown parser. And then we're just resolving a path, loading a file, converting it to HTML, and returning that. And then we have some boilerplate for a Dojo widget. In this case, we're pulling in a block. We're pulling in some TypeScript version of JSX, pulling our markdown in and some other dependencies. But then our actual render function is just using what's called a meta. What a meta is in Dojo is it takes things that normally require you to access the DOM and just provides them as reactive properties to work with directly. So the idea in Dojo is you never sort of say, oh, I actually need the DOM, I'm going to break the reactive architecture. Instead, we just give you the reactive architecture and the properties that would be used. So for things like intersection observers or web animations or things like that, you still can follow that architecture. So basically, we're grabbing a markdown file, populating it into the tree. So really straightforward. There's an example here that includes this, and it's runnable, and it's a PWA, and it gets a 100 out of 100 on all the Lighthouse tests and everything like that. So it's at bit.ly/cityjs dojo blocks if you want to try it out at home. So really all we've done is we've said, OK, we really like Gatsby. We really like the approaches that we've seen others use. But if we have control over sort of the full framework and the full render cycle, we want to be able to take advantage of that and create components that are easier to reuse, and then define blocks for common behaviors. So we could imagine having blocks for markdown parsing, blocks for sort of defining all the different scaled images you might want, and sort of any other thing you might think of doing for build time rendering. And if you go on GitHub under the Dojo repo, I think it's github/dojo/site, we're actually redoing the entire Dojo site now using these concepts. So we're kind of dogfooding all these APIs and figuring it out. To sort of summarize, there's a lot of different approaches you can take. And to be fair, compared to 5 years ago, any of these approaches are pretty good, right? All of these things make our applications faster. But if we really think about, we really have the benefit of being flexible and fast. The only con potentially is the time to interactive is greater than the first contentful paint. But compared to some of the others, I think we have a lot more flexibility, we're quite a bit faster. And what you're really scaling on is your JavaScript size. So you'll see some of these traditional mechanisms like static HTML, it's really based on your deploy side. Your SSR plus rehydration is sort of how many servers you can throw at the problem. But still, we're scaling by the JavaScript size. So if you still try to serve 4 megabytes of JavaScript, it's still going to be slow. It's just going to paint a little bit faster and be interactive a little bit faster, and then you're still going to load all that stuff. One nice thing Dojo does is it really optimizes for that initial bundle. I'm not trying to sell you on Dojo. I'm very passionate about it, obviously. I've been working on it for a little while, 15 years. I think some of you were probably in diapers or nappies back then, so that's good. So back to the title. Was it bitter, fister, awesome? I don't know what it is. It is nice. Build time rendering, fast and awesomer alternative to server-side rendering. So that's the puzzle served. A few quick things before we hand it over to Smush, like 30 seconds if my remote works. There we go. All right. So we create Milestone Mayhem, a card game that looks at the ups and downs of software development. There's some excited people in the crowd that have played it before. I have about 10 copies of it, so find me at the after party and ask me a good question, and you too may receive a copy. We do the TalkScript podcast, talkscript.fm. We have a lot of fun, interview a lot of great people. And I work with SitePen, where we do lots of great work with JavaScript. We work on a lot of open source. We do a lot of consulting. We're spread across the US and the UK. We all work from home. And thank you.